Alrighty guys, so we're going to go over problem number 25 from our single worksheet today, the one that I suggested you guys do to make sure you prepare for the test tomorrow. So we're going to go over the assigning of the variables, the constraints are also the inequalities, and also setting the objective function, as well as graphing it and then answering the question. So, let's first start by assigning our variables. So it says the baking club at HHS makes boxes of cookies and donuts for the coffee grounds. Long-term projections indicate an expected demand of at least 5 boxes of cookies a day and 3 boxes of donuts each day. Because of limitations on production capacity, no more than 12 boxes of cookies and 10 boxes of donuts can be made daily. To satisfy the coffee grounds contract, a total of at least 13 boxes of baked goods must be made each day, not much be made each day. If each box of cookies sold results in a $1 loss, but each box of donuts produces a $3 profit, how many of each type should be made daily to maximize net profits? Now, you're going to have a problem on the test tomorrow where it involves loss and profit. So we need to make sure we know how to deal with that. But first off, let's assign our variables. And our question can help us out. It says how many of each type should be made to maximize profits. So we want to know how many of each type, meaning how many boxes of cookies, how many boxes of donuts. So for X, we're going to have number of boxes of cookies, and then Y is going to be number of boxes of donuts. Alright, sorry guys, this is going to be a little sloppy. I'll try to do my best, but the sweet stylus just doesn't work too well. Alright, so next we want our inequalities. Or constraints, excuse me. So we're going to start with our long-term projections, indicate that an expected demand of at least 5 boxes of cookies a day and 3 boxes of donuts each day. So those are going to be two separate inequalities. Our boxes of cookies are X, that's the number of boxes of cookies, and we want at least 5 of them, so it's going to be X is greater than or equal to 5. And then for our, that's where we got it right here. And the other part will be 3 boxes of donuts each day. Here, let's do a different color. I got loads of colors here. Alright. So Y is greater than or equal to 3. Because of limitations on production capacity, no more than 12 boxes of cookies and 10 boxes of donuts can be made daily. So we have, if no more than 12 boxes of cookies can be made, that means X has to be less than or equal to 12, because X is the number of boxes of cookies, and we can't make any more than 12. And then the next one is going to be our Y. Y has to be less than or equal to 10, because that's how many boxes of donuts we can make. I got that right here. And let's get that blue one back. That's where we got the blue. And then we have one more. And why don't we we'll use purple on this one. Oh, sort of purple. Alright. To satisfy the coffee grounds contract, a total of at least 13 boxes of baked goods must be made each day. So we're talking about the entire part that's going to be shipped to them. So we're going to have X, which is the number of boxes of cookies, plus Y, which is the number of boxes of donuts, is going to be at least 13. So greater than or equal to 13. And those are my constraints. and make sure we can graph this, I'm going to solve it, and I'm going to subtract x. I'm going to get y is greater than or equal to negative x plus 13. Are there any questions? I'm just kidding. I can't answer questions. That's not this cool. All right. So if you guys are, feel free to pause it, move back, whatever you need to do to make sure that you understand what's being explained here. So the next part is our objective function. So for our objective function, I'll even use another color. I will use gray or something different. How about we go with an orangey color, actually. All right. So we got orange for objective. Well, it says we have a $1 loss and we have $3 profit. So the $1 loss is for so your box of cookies is a $1 loss. And then we have boxes of donuts produce a profit. So what we have here is P equals negative x, or negative 1x, plus, well, $3 times the amount of boxes of donuts. So that's our objective function. That's going to help us answer the question. So for now, why don't we go back to graphing these. So for my x is greater than or equal to 5, I'm going to have a vertical line through 5. So I go 1, 2, 3, 4, and 5. And since it's greater than or equal to 5, I know that I am shading on this side. And then, let's see here, for the y, it's greater than or equal to 3. So 1, 2, 3, go right up here. And I know it's greater than, so I'm going to be shading above the line. Now for 12, or x is less than or equal to 12, I'm going to be going over to 12, so let's see here, 6, 7, 8, 9, 10, 11, 12, I think it's about right here. Yep, that's 12. And I'm shading less than, so I know it's going to be over here. And then y is less than or equal to 10, so I get 3, 4, 5, 6, 7, 8, 9, and 10. Shading below. So I know it's in that little box right now that we have. Okay, I know I'm in that little box right now. And the last one, though, I got to have the purple line there. So I'm up at 13, so I'm up here, and I'm going down 1 over 1. And since it's greater than or equal to, I know it's shaded above. So this means I'm going to have this whole area right in here shaded. So my corner points are going to be as follows. This guy here, this one here, 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 and here. So I'm going to do the rest of my work down in this area. Well, let's start with this guy being A, this one is B, C, D, and E. So my first one's going to be, let's see here, 5, and then I'm going to add 8. So 5, 8. And then for B, I'm going to be at 5, 10. For C, I'm going to be at, let's see here, 12, 10. And then for D, I'm going to be at 12, 3. And lastly, for E, I'm going to be at, let's see here, 10, 3. So as I calculate these, and now I get my plug them into my objective function, I'm going to put the answer on the right-hand side. So when I plug into the first one, I'm going to have negative 1 times 5 plus 3 times 8, and that's going to give me 19. For the next one, I have negative 1 times 5 plus 10 times, or 3 times 10, and I get 25. And then I have negative 1 times 12 plus 3 times 10, and I get 18. Negative 1 times 12 plus 3 times 3 for the next one, and I get negative 3. Well, I know that can't be, if I'm going to maximize, that's negative, no way. And then negative 1 times 10 plus 3 times 3 gives me negative 1. So, what I can see here is that my max profit is going to come from this one. And my question is asking how many of each type should be made. How many of each type should be made daily to maximize net profits? Well, that means that my answer is not 25, but the amount of each I should make in order to get my $25 of profit. So I'm going to have, let's see here, 5 boxes of cookies, and I'm going to have 10 boxes of donuts. Alright, so there's my answer. Hopefully this helps you guys out. Coming tomorrow morning if you guys have any questions. I'll be around after school as well. And as always, keep it real, keep it fresh, and always remember to do your best.